An integral part of any machine shop is its ability to design and build tools and fixtures for high production jobs. There's some very simple things that we can purchase right over the counter to very elaborate things that we can build to hold specific parts for second and third operations. So really the imagination is the limit when it comes to different holding fixtures. Let's take a look at a few simple ones and their designs and how they work for high production parts. The simplest is just a basic production stop. Little spring-loaded gizmo. We showed you this earlier and how it mounts on our machine vise. Okay, we're simply going to install it over the top of the jaw, and at this point we've established one of the simplest work holding fixtures going. Any type of part that we slide into the vise simply comes up and comes in contact as a stop, limiting fore and aft movement. We want to be sure and keep the chips out when we're using this type of a work stop. This is another fixture that we've done. Rather than put our part into an indexing head, for work in the Bridgeport, we've simply taken a piece of round stock, machined 4 flats, 90 degrees apart, around this. This acts as a locating fixture for us. As an example, we can set it on our tooling block here. For just a reference, in this position we can come in, drill holes, mill slots, index the part 90 degrees, come in for another series of holes, index it another 90 degrees, and repeat the same operations. This, in conjunction with the work stop, is a very efficient way to produce this part. You don't have to go through a lot of elaborate tooling costs. It's just simple Yankee ingenuity, if you will, in order to perform these tasks. All right, now let's take a look at another type of fixture, something that's a little more elaborate. It's going to require the use of a couple of parallels to hold it up in the vise. And while we're on the subject of parallels, let's take a look at a unique type of parallel called an adjustable parallel. This is an adjustable parallel, and you can see that it is on a dovetailed slide. So we can either increase or decrease the height simply by sliding the two back and forth. If we have a special job that we need to mount very high in the vise, we can simply use an adjustable parallel and fine-tune the height. Parallels come in a variety of different sizes. Oftentimes, if we're dealing with a difficult part, though, we need to have something that is fully adjustable, allowing us to grip the part accurately for our next machining operation. In order to lock it in place, we simply take our screwdriver, once we've adjusted it to the proper height, and cinch these little gib screws, if you will, holding it in place. Now it's solid, just like a conventional parallel. These come in sets. They're available from all of the different tool manufacturers, so get out a copy of your MSC catalog, look under adjustable parallels, a great addition to your machine shop. All right, now let's take a look at another tooling fixture. This is a special tooling fixture that we design and manufacture for drilling holes in this little lug. You can see that we've used 3 dowel pins strategically located to align the part. We've built a little clamp that will come into place, and when the lug is held against those 3 pins, we simply tighten the clamp. It's going to set inside our vise jaws, so again, doesn't require tearing down the mill in order to get the job done. We simply clamp our fixture in the vise. We'd come in with our coax indicator, indicate the center of our bore in the lug, and then have the correct amount of offset, enabling us to drill this hole. Part after part, we simply keep the chips out of the way, align it, put our little step clamp over the top, tighten it down, center drill it with the appropriate size drill, and we're ready to go. So now you're getting an idea of just how simple some fixtures can be to hold apart. Alignment becomes critical. We need to be working off of different surfaces that we can control in the earlier machining process of the part. Try and keep in mind, anytime that we are locating something, it's got to be repeatable. If this dimension is varying, if this dimension is varying, that's going to throw a wrench in the gears as to our ability to locate that hole accurately. So it must work in conjunction with tolerance levels to be able to have consistency in our parts. If these dimensions varied considerably, but our hole was very consistent, we would use the hole then as a location. We would use something in a large pin that fit that particular hole and simply sleeve the part over the top, align it possibly with a dowel pin here or a pushing removable slide, and then we could drill and locate our hole. So be flexible as to the type and design of tooling fixture to hold a specific part. Try not to have tunnel vision in the machine shop. Another unique fixture is one that we build allowing us to flute bolts for the Remington 700 series of rifles. I'll show you an example of a fluted bolt. You can see the different flutes in the bolt body. Adds a little bit of gingerbread to the rifle, reduces the weight. Very simple and easy to do. A lot of people would try and support this bolt between centers. The problem with that is that the firing pin hole and the driving hole in the back for the cocking piece and bolt shroud is not always concentric. So as we rotate this part, we get an oscillating effect of the bolt body, and our flutes do not come out parallel. So I designed a very ingenious part that allows us to lie the bolt body, which we know is cylindrical and true, into a miniature V-block. We showed you how to mill a little V-block earlier, and then simply have two overarm clamps to hold it in place. And again, it can come in to our vise. We always try and use the simplest hold down methods possible for time and efficiency, and we would simply rotate the bolt. We've got a removable pin in the front which acts as our work stop. We push the bolt up to that position, locating the fore and aft movement. Also controls the length and consistency of our flutes. Now for the back, in order to time it, we've machined up these little slugs that screw into the back. So once we've established the location of our flute, we simply screw this into the back of the bolt, tighten it down, and use it as a reference indicator for indexing the bolt depending upon the number of flutes that we decide to machine. We also have a larger version that you can see with all of the different facets on it, indicating a much finer flute spacing around the circumference of the bolt. And again, this would simply screw into the back of the bolt. Once we've established the location of our flute, we would simply align this and continue to rotate and reference off of the flats that have been machined on our flange. Okay, so again, very simple. Tooling does not have to be complex. The Russians had a pretty decent idea during World War II in the design and construction of a lot of their tools and armaments. The designers were given the types of tools that their product must be produced on, a welder, a riveter, a saw, whatever. Those were the limitations, and they had to try and design specific parts and pieces around those toolings. They didn't have the luxury that we did in America at that time with a vast manufacturing facilities with all of the latest design techniques, developments, tools, machines, etc. They were very limited, yet they managed to produce a considerable amount of production with those limitations. All right, another fixture that is relatively inexpensive, comes in awfully handy, is the very simple spin fixture. Very simple and easy to do. It works off of a 5C collet. It's divided into degrees, and we can simply rotate this around for drilling hole patterns, machining flats, facets, whatever we need to do. Let's take a look at the back and how it operates. You can see we've got a degree wheel on the back. We could clamp this in our vise or simply bolt it to the table. It is graduated in 5-degree increments for a total of 360 degrees. We can look, and very similar to the veneer that we looked at earlier, we have a hole spacing across the bottom and an index pin. The index pin, when it is left on 0, okay, that indexes in 10-degree increments. If we want to break it down even finer, we have holes marked 1, 2, 3, 4, 5, all the way to 9, varying those amount of degrees on the index spacing. It's not extremely accurate. It's not like having a rotary table or a manual indexing head, but it's good enough for the majority of simple indexing practices that you may encounter in the shop. Simply start at 0 with your index, pin in the 0 hole. If we want to drill something in 30-degree increments, simply turn it, locate our pin, make our machining operation, remove the pin, index, so on and so forth, all the way around the circumference of our part. A worthwhile addition to the machine shop for simple indexing. Okay? If you're going to get into complex indexing, by all means, you're going to need a rotary table or an indexing head that divides the circle up into degrees, minutes, and seconds, depending upon how accurate your application is. All right, that pretty well covers a lot of the simple fixtures. Now let's take a look at some more complicated, more expensive fixtures for the mill.